chemistry. Imagination to instill scientific endeavor, research, and implication for a better world. On that thought-provoking note, a very warm morning to everyone. I, Sohail Khan, a student of 12A, the host of the chemistry seminar, extend a hearty welcome to Honorable Principal Ma'am, Mrs. Ipshita Das, esteemed judges for this event, revered teachers, technical staff, and my fellow mates as an audience on the virtual platform. We all are aware of the fact that a seminar is a form of academic congregation offered by the school to discuss and negotiate over presentations brought forward by students, focusing over a particular topic. There is immense value of a seminar in a student's life. To list few, they include improving communication skills, gaining expertise over an assigned topic, cooperative discussion, including multiple speakers, and opportunities to share varied perspectives, networking with fellow mates, and renewing motivation and confidence. In simple words, it happens to be an incredible learning experience for each one of us. With that thought in mind, I feel immense pleasure to introduce the topic for today's chemistry seminar, that is, applications of the photoelectric effect. Before further proceedings, let us seek the blessings from the Lord of Prosperity and Wisdom, Sri Ganesh, for a successful event through the chanting of the auspicious Ganesh Vandana.
वक्रतुण्ड महाकाय सूर्यकोटि समप्रभा निर्विघ्नं कुरु मे देव सर्वकार्येषु सर्वदा.
I take the honor of requesting Principal Ma'am to please address the August gathering. Dear audience, I would like to introduce our judges for today's seminar. Please acknowledge the presence of Sir Mr. Sanjay Kumar Sarangi, Senior PGT Chemistry, Chandrasekharpur. Sir, we welcome you to this seminar. Our next jury member is Madam Mrs. Mausumi Patnaik, PGT Chemistry, Pokharipur. Ma'am, we welcome you. Now, I take this opportunity to present the rules and guidelines of today's seminar. So without further delay, let us welcome our first presenter, a student with remarkable scientific forward, Ms. Adya Archita Patnaik of 11B, to showcase her ideas through a PowerPoint presentation. Adya, the platform is set and you have the floor for the next 5 minutes. Thank you.
Good morning, teachers. Now I'm going to speak on the topic, the applications of photoelectric effect. Is the presentation visible?
Yes, the presentation is visible. You can proceed. Or you haven't shared your screen yet.
Is it now shared?
Yeah, it is visible. You can proceed.
Good morning, teachers. Now I'm going to speak on the topic, the applications of photoelectric effect.
Excuse me, Adya, sorry for interrupting you, but your screen is not visible.
I think I'm experiencing some issues.
Okay, so can we just move on to the next participant?
Can you not, can it, is it a share?
Yeah, now it's fine.
I think I'm experiencing some issues. My screen share is getting disabled.
For now, can we move on to the next participant? Now I take the opportunity to invite our next participant with a great innovative wellness, Ms. Adyasha Abhijita of 12A. Adyasha, you have the floor for the next 5 minutes. All the very best.
I think my issue is not solved. Can I share?
Sir, can I share my screen?
Adyasha, please hold on. Yes, Adyasha, you can share your screen.
Sir, is my screen visible?
Yes, Adyasha, your screen is visible.
So can I start?
Yes, you can.
Despite the popularity of Einstein's theories of relativity and his musings on black holes, Einstein's Nobel Prize was actually awarded for his discovery of the photoelectric effect. The discovery revolutionized our understanding of the world around us. A propitious morning to every patron here. I, Adyasha, going to enunciate my seminar topic, Photoelectric Effect in the Contemporary Earth. To realize the photoelectric effect, we need to dig a little into the history of discovery. The first clearly successful attempt was by Heinrich Hertz in 1886 using a high voltage induction coil. The experiment that scattered the fundaments was carried out by J.J. Thomson in 1899. In 1902, Leonard studied how the energy of the emitted photoelectrons varied with the intensity of the light. Einstein resolved this problem using Planck's revolutionary idea that light was a particle. Defining the photoelectric effect, the phenomenon in which electrically charged particles are released from or within a material when it absorbs electromagnetic radiation. External photoelectric effect. This effect is utilized in vacuum tube photodetectors, phototubes, and in street cameras. Internal photoelectric. In infrared cameras, the band gap energy is so small that the substantial thermal excitation occurs at room temperature. To avoid that, such detectors need to be operated at lower temperatures, example, using a Stirling cooler. So, how can this fit into the realism of our life? Attosecond laser pulses have made it possible by the extreme temporal confinement of the light-matter interaction, which opens a new road in the attosecond science. It foreshadows the applications such as image intensifiers for night imaging, sources for next-generation electron beam lithography. It has also led to the elucidation of novel materials. Coming on to X-ray, for the very first time, scientists from the Technical University of Munich have now measured the absolute duration of the light absorption and of the resulting photoelectron from a solid body. For this purpose, the physicists glued individual iodine atoms to a tungsten crystal and exposed it to an X-ray flash, which triggered photoelectric effect. Because the iodine atoms react extremely quicker to incident X-rays, which serve as light and electron stopwatches. Moving on to ultra nanocrystalline diamond. When it comes to producing high quality electron beams like those found in state-of-the-art scientific equipment, scientists have looked to photocathode technology as a way to convert light to electrons. Normally, pure diamond acts as an insulator, but UNCD, it can be tuned through different doping techniques to behave like a semi-metal and shows higher quantum efficiency value than the best metallic photocathodes, excellent vacuum tolerance, and better than all semiconductors. A knowledgeable fact is that the recent photoelectric apparatus at Kettering University, Michigan, is being used for a longer time, where photoelectric uses a vacuum tube photocell followed by an operational amplifier. The global pandemic, COVID-19, will reshape our country and world. We don't know when this crisis is going to have an end, but we can be sure by the time it does, our world will recon different. Radiotherapy. I'd like to draw the community's attention to the potential for low doses of LET radiation to treat viral pneumonia as a possible therapy for COVID-19. It was uncommon in the early 20th century. A review showed low doses from kilovoltage X-rays reduced pneumonia mortality from roughly 30 to 10% to treat COVID-19. Moving on to Spectroscopy, although the definitive diagnosis of COVID-19 is based on RT-PCR test results, the diagnostic findings, notably those seen on chest CT, are important when RT-PCR results are not available. It is also crucial in evaluating the extent of lung lesions, thereby identifying those patients who require close monitoring. In the present day study, we report the first retrospective data from the spectral chest CT, the detection of early stage COVID-19, a stage for which it has limited sensitivity for detection. Moving on to Psychocan is a device that could attenuate 99.9% of coronaviruses in enclosed spaces. However, it involves a lots of technical jargon about electrons, negative charges, and the novel coronavirus spike protein. Briefly, Psychocan can allegedly produce a large number of charged particles through the photoelectric effect. That is, when photons of light strike certain metals, they knock out some electrons. An everyday application of this phenomenon is to produce electricity from solar energy. But in this very well-known principle is supposed to create trillions of electrons that will float around a room and specifically inactivate the novel coronavirus spike protein. Since the spike protein is what allows the virus to infect people by attacking to human cells, inactivating this protein should render the virus harmless. So, does photoelectricity deserve a thumbs up? At last, I would end my presentation saying innovation is the key to use photoelectricity to help serve society during these challenging times, and we can trust that our efforts will turn valuable. Thank you.
Thank you, Adyasha. Truly an innovative exposure it was. Judges, do we have any question for Adyasha?
Adyasha, can you hear me?
Yes, sir. Yes, sir.
Okay. Just before you told that photoelectric effect is used to the trick is used to treatment of coronavirus, lungs, basically lungs infection. Can you explain how the digital value of lungs? You are telling the say lungs the infection level is 7, 9, 10, above 7, below 7 mild, or below 10 is mild, above 10 is harmful. So what is that number?
So
That
what?
CT
I didn't get you.
That coronavirus treatment on the basis of CT scan, to what extent
Yes.
the lung is affected or lung is infected by the virus. It is measured
Yes,
in
sir.
terms of a number.
Yes, sir.
No, WHO that values given that below 10 we are telling that it is mild, and above 10 it is serious, particularly above 13. What is that value?
So means you are asking about the value,
Yes, CT scan value.
CT scan value for lung lesions.
Yes, or coronavirus, corona treatment. Do you know that?
No, sir. I know that above 10, it is treated as extreme.
Not extreme. Above 10, it is dangerous. Considered as a danger level.
Yes,
Below
sir.
10, it is moderately or mild. It can be treated at the home. Do you know that? You are telling, therefore I am asking. You are using that concept, CT scan concept in your second column, na?
Yes, sir.
Okay, Madam.
No, sir.
Thank you. A very nice presentation.
Thank you.
Okay. So Adyasha, very nice presentation.
Thank you, ma'am.
Okay, Adyasha, my question is that once what you had given a brief account of all the things, what sir was asking, I was asking the same thing, that you had used a photoelectric effect for your CT scan. But
Yes, ma'am.
There also you need to, sir has also told the input which I was going to ask. You had to say the values also, okay? in
Yes.
your further info, when you will present and all, gather all the information related to that so that it will be easy to present. And judges actually, we as a judge, we can give you inputs. So better your presentation only. Okay. So my this question is that you had taken the history and application part only you had given over. Can you tell me that application part in brief again?
Ma'am, which
What
one?
are
I had taken two things in application. One
Hmm.
is recent things in normal, and another one in coronavirus, COVID-19 related.
Yeah, this recent pandemic only. I'm asking you about this recent
Yes,
pandemic.
ma'am. One thing I had taken radiotherapy, another
Hmm.
one I had taken spectrality, and
Hmm.
another one I had taken a device which is known as Psychocan, which is invented
Can
in
you?
India
Yeah,
only.
yeah. This last one I need you to explain.
Yeah, ma'am. Ma'am, Psychocan is only invented in India, Bengaluru. The name of the scientist is Raja Vijay Kumar, who runs the organization Days Kalini.
Hmm.
Before he invented this Psychocan in device for normal flu and common cold. As coronavirus and these two belong to the same family, it was found effective for the use of also COVID-19. So
What
that's
does
why
this?
it is a
What does this device do? Means
ma'am.
in this device.
Ma'am, for
Hmm.
example, if we fix it in a office, when
Hmm.
a certain meeting or something is going on, if it strikes on any metals, such as anything, metal,
Hmm.
anything is there on metal or semi-metal, anything is there.
Hmm.
If the photons of the light strike on that metal, the
Hmm.
electrons evolve, emission of electrons take place,
Hmm.
and it attenuates the virus.
Okay. Means you are saying that if a person is nearer to that device only, then it will detect that that person is infected or not.
Yes, ma'am. No. Ma'am, if if a person is suffering from coronavirus and he is there in the office, in that
Hmm.
enclosed surface, then it will not harm others. Means it will attenuate, means it will decrease the amount of
Means it is
virus
acting as
present.
a kind of filtration.
Yes, ma'am. It is known as the guide for COVID.
Okay. Thank you.
Yes.
Nice
Thank you.
presentation.
Thank you, ma'am.
Yeah. Next.
Thank you, judges. Now we welcome our next participant, Master Anish Padhi, with an enthusiastic scientific mindset to showcase his presentation. Anish, the platform is set and you have the floor for the next 5 minutes.
Am I visible and is my PPT visible?
Yes, Anish, you are visible and your PPT is also visible. You can go ahead.
Very fresh morning to all the esteemed dignitaries present in this virtual platform. Today, I, Anish Party of Class 12 and Section B, is present over here to state my views on the applications of photoelectric effect. First of all, let us know what photoelectric effect means. Photoelectric effect is the phenomenon in which electrically charged particles are released from or within a material when it absorbs electromagnetic radiations. This effect is also defined as the ejection of electrons from a metal plate when it absorbs light of sufficient frequency. So we can summarize it as when a beam of light of sufficient frequency falls onto a clean metal surface, then the light will cause the electrons to leave the surface. And it is very clear from the video that I have shown here. It was first discovered by Henry Rudolf Hertz in the year 1887. Now let us move on to its work function. When a beam of light falls on the photosensitive metal plate C, which is also called as an emitter, it emits the photoelectrons due to the photoelectric effect. The photoelectrons emitted by the plate C will be attracted towards the positive plate A. These electrons flow in the external circuit to cause an electric current in the circuit. Such a current produced due to the effect of light is measured by the micrometer connected in the circuit, and such a current produced with the help of light is known as a photoelectric current. Now heading on to its characteristics of photoelectric effect, the threshold frequency is different for different materials. Photoelectric current is directly proportional to the intensity of light, meaning if the intensity of light increases, then the photoelectric current also increases. The kinetic energy of electrons is directly proportional to the frequency of light. The stopping potential is directly proportional to the frequency. And last but not the least, this process is instantaneous. The practical applications of the photoelectric effect include photovoltaic cells, photoconductive devices, and solar cells. The PV cell consists of 1 or 2 layers of a semiconducting material. Usually we take silicon. When the light shines on the cell, it creates an electric effect at layers, causing the electricity to flow. This conversion is called as the photovoltaic effect, which was discovered in the year 1839 by the French physicist Edmond Becquerel. And the greater is the intensity of light, the greater is the flow of electricity. Now let us know about the second application of this amazing effect, that is the photolytic reduction of carbon dioxide. The conversion of carbon dioxide into fuels and value-added products is one of the most significant inventions to address the global warming and the energy needs. The photochemical reduction of carbon dioxide is considered as an artificial photosynthesis technique that produces formate, formaldehydes, formic acid, and etc., which are very useful in the laboratories for the research work. A team of scientists have discovered a single site visible light activated catalyst that converts carbon dioxide into useful molecules that could be used in the manufacture of other useful chemicals. This discovery opens the possibility of using sunlight to turn into a greenhouse gas into a useful chemicals. And now converting carbon dioxide into different useful compounds and chemicals, for like example, CH3OH, methanol, CH4, methane, and other compounds has a valuable real world applications. So it would be nothing wrong to say that by breaking carbon dioxide, we can kill 2 birds with 1 stone. And the key ingredient required to break the bonds of carbon dioxide is a sufficient flow of electrons, which can be generated when a material of which can be generated when a material known as a semiconductor gets activated by the energy in the form of light. The light, which is monochromatic in nature, kicks the electrons out, making them available for the catalyst to carry out the reaction. The catalyst, after receiving the electron, gets activated and breaks carbon dioxide, which is further used to make different useful compounds like methane, methanol, formic acid, etc. So to make it more clear, I have shown a figure here. From the figure, it is clear that the setup is divided into 2 compartments with the help of a protein exchange membrane. In the first compartment, the water is broken by the light and certain radiations, and the oxygen is released out from the compartment, and the H plus gets transported to the second compartment where carbon dioxide enters and it is mixed with the hydrogen to form a number of useful compounds. So I would conclude my presentation here. Thank you for your patient hearing.
Indeed, a great presentation. Thank you, Anish. Judges, do we have any questions for Anish?
How the frequency related to kinetic energy? Totally directly proportional. Why?
Sir,
And
could
you
you please
told-
repeat your question?
How the frequency of incident light is related to kinetic energy of the photoelectron? That is number 1 question. And second question you are written, second thing you are written in your slide, that photoelectricity directly proportional to intensity, light intensity. Can you explain how the photoelectricity depends upon the intensity?
Sir, first of all, the kinetic energy of the electrons is linearly proportional to the frequency of the incident radiation, which is above the threshold value. And the kinetic energy is independent of the intensity of the radiation.
Right. That is correct. The kinetic energy is directly proportional to intensity, frequency, light frequency. But another thing you written that photoelectric electricity, you written photoelectricity or photoelectricity?
Yes, sir.
Directly proportional to the quantity, directly proportional to intensity. Can you explain?
Yes, sir. Sir, more is the amount of light falling on the metal surface, then more is the number of electrons that will eject from the surface.
Okay. Suppose I will allow the light intensity to very high intensity, but frequency less than threshold frequency.
Yes, sir.
So how much time is required to eject the photoelectrons?
Sir, as the frequency is below the threshold frequency, then the electrons will not be ejected.
So whatever the irradiation time may be, there is no ejection.
Yes, sir.
Okay. Can you explain mathematically on the basis of Einstein's equation how the frequency kinetic energy related? What is that equation exactly? In graphical form, you know, in your post-nuclear 11 class. Have you remembered?
Sir,
Okay, thank you. But good
Thank you, sir.
presentation.
Thank you, sir.
Nice presentation, Anish.
Thank you, ma'am.
Yeah, my question is that, can you tell me which metal we can use for photoelectric cell?
Ma'am, we can use silicon.
You can use silicon for photoelectric cell. Which characteristic of silicon will help it to be, which characteristic is amicable for this? For
Ma'am,
which characteristic?
Ma'am, it can convert the sunlight into the, it can, we can use it to convert the light energy into electrical energy.
Only that characteristic, no other characteristic is required.
Yes, ma'am, more characteristics are there.
Actually, this is there in your content also. You may have read it in class 11 also. Which for photoelectric cell, which metals are generally used? Just think. Okay, so think about that. Okay.
Yes,
okay.
ma'am.
Okay, nice presentation. Thank you.
Thank you, ma'am.
Okay, we'll go for the next presentation.
Thank you, judges. I take this opportunity to welcome our next fervent participant, Ms. Anjali Mishra, to share her presentation. Anjali, you have the floor for the next 5 minutes.
Is my screen visible?
Yes, Anjali, it is visible. You can
Am I
go ahead.
audible?
Yes, you are perfectly audible.
Okay. Fluorescence and luminescence is not just a simple material or a simple exhibiting property. It tells a lot about scintillation. And so, scintillators form as one of the most major applications of photoelectric effect. With this note, a very warm morning to everyone present over here. This is Anjali Mishra, a student of 11A, and I'm here to present on my topic, scintillator. Well, before getting to know about scintillators, let's think, what does this very name, scintillator, suggest us about? A scintillator is nothing but any machine, device, material, or substance which exhibits a very property scintillation. And scintillation is a property of luminescence, to exhibit and to emit the light when excited by ionizing radiation. When different electromagnetic radiations and other ionizing radiations like the alpha ray, beta ray, and the gamma rays get incident on the scintillators, then these convert the high energy photons into the low energy photons and help them to emit the electrons through photoelectric effect. A scintillation is obtained when photomultiplier tubes absorb the emitted light by the scintillator and it re-emitted in the form of electrons through the photoelectric effect. This can also be understood by the below pictures, where we can see that a scintillator, which forms the first part and the initial part of photomultiplier tubes, helps the scintillator to emit the light and to form different kind of electrons, which can be used to get to know the meaningful analysis and information at the particle level. Now, if we talk about the very mechanism of scintillators, how do these scintillators work? Well, if we try to connect a photomultiplier tube, that is a vacuum tube with several electrodes in it, scintillators are joined at the initial part of these photomultiplier tubes. When the radioactive radiations are incident on phosphor, they produce scintillation. After scintillation, this light repeatedly passes through several diodes and several other electrodes in the photocathode of the photomultiplier tubes. This basically works on the principle of secondary emission. As a result, when this light is passing through several diodes, there are multiple replication of the photoelectrons, and this produces an electrical pulse. When this electrical pulse gets ended with the last diode, it gives the particular information about the amount and the particle which was used in the beginning of the scintillator. For example, let us imagine that we are making the gamma rays incident on the scintillator. Now, the photons from the gamma rays will get incident on the scintillators, and these scintillators will convert them into low energy photons and pass it to the photomultiplier tubes. These photomultiplier tubes will churn out these electrons, and due to repeated incidence and reflection of these electrons, it will produce a meaningful information, and at the ending, we'll be able to detect that whether it was a gamma ray or not. This subsequent method is used in several radiation detectors and scintillation detectors, as we can see in the below diagrams. Moving on to the different types of scintillators. Though we have a lot of scintillators, the common form of scintillators are organic crystals. From the name itself, these are the aromatic hydrocarbon compounds, that is, the compounds made up of hydrogen and carbon. They also contain benzene ring, that is 6 carbon attached in a ring structure. They interlink in various ways, and they are the most common form of scintillators in chemistry. The very example we can have is anthracene. Anthracene, a component of coal tar, has the highest light-giving output and is also one of the best scintillators. Talking about the next type of scintillator, we have plastic scintillators. The term plastic scintillator typically refers to a scintillating material in which there is a primary fluorescent emitter. We can name it as a fluor, and that is suspended in the base, which is called as a solid polymer matrix. When a fluor is suspended in the base, that forms the plastic, and these plastics, they help in acting as scintillators. The third kind we have is gaseous scintillators. The common gases we know, that is especially the noble gases like helium, argon, krypton, xenon. These gases, they have the property of de-excitation of single atoms when there is a passage of an incoming particle. We can even see the de-excitation state and the scintillating state of helium in the first picture. We can also see the de-excitation state of xenon in the second picture. So these form as the most common gaseous scintillator. They contain nitrogen and all of the noble gases. The fourth kind of scintillator we have is glass scintillators. The most common glass scintillators we have are cerium-activated lithium or boron silicates. These are the chemical compounds which possess the properties of a glass and are hence useful in making different sorts of scintillators. Let's come to some of the properties of scintillators. Because these scintillators are used in front of the photomultiplier tubes and other photocathodes, they need to have high density, fast operation speed, low cost, radiation hardness, and production capability. The application of scintillators. Scintillators can be used in particle detectors, can be used for new energy resource exploration, in different X-ray security, nuclear cameras, computer tomography, and gas exploration. In fact, they're also used in different computer monitors and television sets, starting from cinematography to different medical diagnostical fields. Scintillators find out a variety and a wide form of applications. With this, I wind up my presentation. Thank you.
Thank you, Anjali, for that wonderful presentation. Judges, Anjali is eagerly waiting for your questions. Please go ahead.
Yeah, good morning, Anjali.
Good morning, ma'am.
Okay, Anjali, you have taken the picture of LED.
Yes, ma'am.
Now, can you tell me inside LED what is present?
Ma'am, we are having different noble gases like helium, krypton, which differs in different LED lights. That is used for scintillation purpose.
We are using noble gases only.
No, ma'am, there are other chemical compounds also, but for scintillation process, the noble gases are used. So gaseous scintillators are used, and also in certain kind, they keep the cerium activated lithium scintillators. Those are also used.
Okay, there are certain also volatile organic compounds which are used in your LED for the scintillating purpose also. You have included this. You had also taken this picture there only, but okay, very good presentation. Thank you.
Thank you, ma'am.
Thank you, Anjali.
Thank you, sir.
Thank you, judges. I would like to invite our next participant with a scientific zeal, Master Ayushman Panda of 12B. Ayushman, you have the floor for the next 5 minutes.
Is my PPT visible?
Yes, it is.
Good morning, one and all present over here. This is Ayushman Panda from class 12P, going to present on the topic applications of photoelectric effect. First of all, photoelectric effect. It is nothing but a phenomenon in which electrically charged particles like electrons or other free carriers emit when light shines on that material. It is used in various fields of physics as well as in chemistry, such as electrochemistry and quantum chemistry. The electrons emitted are called as photoelectrons. Now, moving on towards the history part, this amazing theory was first discovered in 1887 by German physicist Heinrich Rudolf Hertz. This relation between light and energy was clarified in 1902 by Philipp Lenard. After the discovery of this theory, there were several queries and doubts raised against it, which were finally resolved by Albert Einstein in 1905, which we are going to discuss forward. Next, coming to what is stopping potential. Stopping potential is the required potential for stopping the removal of an electron from a metal surface when an incident light energy is greater than the work of the metal on which the incident light is focused. On the right-hand side video, you can see that we have an emitter and a collector. As the light shines on the emitter, it emits some amount of electrons that goes directly to the collector. But below, as we see, as the potential increases, we see the electrons reverting back to the emitter. As the potential value goes on increasing, the more number of electrons emit back to the emitter. Now let's discuss what Einstein gave on this particular theory. There were many postulates of Einstein regarding it. Some of the major of them were photoelectric emission is a result of interaction of two particles. One is a photon and other an electron of a photosensitive metal. Secondly, the minimum energy required to liberate an electron from the metal surface is known as the work function of the metal. The total energy hν of the incident photon is mainly used in two parts. First, it is used, the part of the energy is used in liberating electron from the surface of the metal. Secondly, the remaining energy is used in imparting kinetic energy to the ejected electron. Very few, that is less than even 1% of photons whose energy is greater than the work function of the metal are capable of ejecting the photoelectrons. By the conservation of energy, energy of incident photon equal to maximum Ke of photoelectron plus work function. Now, if we put this mathematically, we find hν equal to half mv square max plus omega naught. Solving it, we get K max equal to hν minus omega naught. In the below diagrams, you can see how photoelectric effect works when light shines on a photosensitive metal. Now we know what is photoelectric effect. Now let's directly get into its application. Photoelectric cell. Photoelectric cell or photocell or photovoltaic cell is an electronic device which works on the principle of photoelectric effect and converts light energy into electrical energy. On the right-hand side diagram, you can see an image of a photoelectric cell with various labels. This cell is made up of an evacuated glass tube containing two electrons, namely emitter labeled as C and collector labeled as A. The emitter is shaped in a form of a semi-hollow cylinder. It is always kept in the negative potential, whereas the collector is in the form of a metal rod and a fixed axis of the emitter. It is always kept on the positive potential, whereas the glass tube is always fixed on a non-metallic base. What are the working of this photoelectric cell? The photoelectric cell is used in sound production, which is used in movies. It is used in an exposure meter, in a lux meter, which is used in measuring the intensity of light. It is also used in burglar alarms. On the right-hand side video, you can see how a photoelectric cell generally works. Now moving on, what are the laws of this photoelectric emission? Emission of electron does not occur for all values of frequency of light. There exists a minimum value of frequency that is needed for the emission of photoelectrons. The number of photoelectrons emitted is directly proportional to the incident of light incident for a given metal and frequency of the light. This frequency is known as a threshold frequency. If the frequency of light incident is greater than the threshold frequency, then the kinetic energy of the photoelectron depends on the frequency of the light and not on the intensity of the light. Lastly, photoelectric effect is an instantaneous process. It means it occurs in no time. The time needed for an incident photon to remove an electron is 10⁻⁹ seconds. Now coming towards the end of my PPT, let's know what is the application of this photoelectric effect in our everyday life. First of all, in solar panels. Solar panels are one of the most common applications of photoelectric effect. The photon from the sun knocks out the electron, producing an electric current. Secondly, photomultipliers. It is a sensitive vacuum tube with a photocathode and some emitter. It is used when low level of light is detected and it converts light intensity into electrical currents. Photoelectric cell that we read sometime previous are one of the most common widely used devices to convert light energy into electrical energy. Now let's come upon scintillators. These are materials that are able to convert high energy radiation such as X or gamma ray to a near visible or visible light. They follow the principle of photoelectric effect. Last but not the least, a light meter is a device used to measure the amount of light. In photography, a light meter is used to determine the proper exposure for a photograph. Towards the end, I would like to say that photoelectric effect is an amazing theory which has influenced each and every part of our life, starting from photography till a research lab. So this was all. Thank you all for your patient hearing.
Thank you, Ayushman. It was indeed an amazing presentation. Judges, now you can ask your questions.
Ayushman, can
Yes,
you
sir.
tell me what are the conditions for any metal to select for photocell?
Sir,
Which metals are usually selected for photocell or photoelectric effect?
Sir, means metals for used in photoelectric cells.
Yes.
Sir,
Any metal can be used.
No, sir. Sir, I have there is a specific metal most used is cesium.
Why?
And it is mainly used in photoelectric cells, sir.
Why?
Because the electrons, sir, the electrons in cesium atoms are directly stimulated by sunlight, and in photoelectric cell, these electrons help in flow. Means these electrons
So
flow
why
to create an electric current.
That is my question. Why the electrons from cesium metal can be easily ejected or stimulated, not by iron metal?
Sir,
Which factor control that?
sir, how the electrons are simulated from cesium metal easily?
Yes.
Sir, low threshold frequency.
Low threshold frequency. So again, question: why?
Yes, sir.
Why cesium has low threshold frequency, but iron has high threshold?
Sir, binding
frequency?
energy is less.
Binding energy. What is that binding energy?
Sir, energy that helps to means the energy needed to bind the electrons together.
We know binding energy applicable in case of nucleus.
Yes, sir. It is the minimum energy that is required to remove an electron from an atom. Low binding energy means low threshold frequency. So the electrons can easily emit when light shines on.
Okay. Thank you.
Thank you, sir.
Yeah, thank you. Nice presentation. Can we move for the next one?
Thank you, judges. I take this opportunity to welcome our next enthusiastic participant, Ms. Arya Patnaik of 12E, to showcase her presentation. Arya, the platform is yours for the next 5 minutes.
Is my presentation visible?
Yes, it is visible.
Okay. Very good morning, everyone. This is Arya Patnaik, a student of class 12E, going to present my presentation on solar cells, which is one of the most important applications of photoelectric effect. Before moving on to solar cells, I would like to briefly define what exactly photoelectric effect is. Photoelectric effect is defined as the ejection of electrons from the metal surface through radiation of a suitable frequencies. Solar cell is made of the application of photoelectric effect. It is also known as the PV cells or the photovoltaic shells. When light strikes at the surface of the metal surface, some energy is absorbed, and the energy particles called as photons present in the light allow the electrons to knock off the metal surface, allowing them to move freely. The various applications of a solar cell include satellites, solar panels, remote lighting systems, water solar disinfection, water pumping, and electric fences. In case of satellites,
The spacecraft operating system in the solar systems mainly depend upon the solar panels for the conversion of sunlight into electricity. Among the two doped layers of a solar cell, the lower layer is called as the p-type or the positive type semiconductor or silicon, since it has less number of electrons and is also known as the electron donor, while the upper layer is known as the n-type or the negative type semiconductor, since it has more number of electrons. The various components of a solar cell include the metal conductors, the N-layer silicon, which is phosphorus doped, while as the P-layer silicon, which is boron doped, and the module and capacitant. After the formation of the p-n junction between the n-type phosphorus layer and the p-type boron layer through doping, which is a method of addition of impurities into the crystal to improve the conductivity, the dopant phosphorus atom has only 5 electrons in its valence atom, but the silicon has only 4 electrons in its valence atom, due to which it forms only 4 covalent bonds with silicon. The extra electron forms as a free electron and can move easily in the entire crystal. While in case of boron, it has only 3 electrons in its valence shell, due to which it forms 3 covalent bonds with silicon. The remaining, due to the lack of an electron, it forms a hole in the crystal, which becomes positive. Due to the doping of the silicon crystal, there are a large number of mobile electrons in the n-type site. Because of the random thermal motion of the electrons from the n-type site to the p-type site, thus forming a p-n junctions. Due to this diffusion, they leave behind the positive phosphorus ions near the p-n junction. The positive holes diffuse the n-type site and set an electric field between the p and n junctions. The photon energy, which is required for the electrons to knock off the metal surface, is given by the sum of the threshold frequency and the kinetic energy of the electron. The threshold frequency is the minimum intensity of light that is required to eject an electron off the metal surface. When these solar shells are connected together and attached together, they form a solar panel, which is used to convert sunlight into electricity, which is one of the most important utilization of the solar cells. Thank you.
Thank you, Arya. It was a creative exposure indeed. Judges, do we have any questions for Arya?
Yeah, good morning, Arya.
Good morning, ma'am. Good morning.
Okay. You are saying, can you tell me that what is the band gap in solar cell? What is the band gap between solar cell?
Ma'am, the band gap, for the conduction, the band gap between the valence and the conduction band is not that much, it's very less, so that due to which it can be used as a semi-conductor.
Yeah, then it is which type of junction then? Solar cell
It
is a means what exactly? It is a
it's a p-n junction.
p-n junction. Okay. Now it generates what?
The electron flow, due to which current is generated. The p-n junction, the moving of electrons from one junction to another junction.
Yeah. So for that only here, because of this, the band gap is around 1.5 electron volt. Band gap is less, but you have to remember the unit also, as it is very less, it is 1.5 electron volt. Okay. Nice presentation. So,
Okay.
Sir.
Thank you. Arya, thank you.
Thank you, sir.
Thank you, judges. Now I would like to invite our next participant, Master Aurobindo Mohanty, for his presentation. Aurobindo, you have the floor for the next 5 minutes.
Is my presentation visible?
Yes, your presentation is visible, but your video is not on.
Is it now?
Not yet.
Recording in progress.
Yeah, you are visible now.
Okay. Myself Arvind Mohanty, and I am here to discuss about the applications of photoelectric effect. So before getting into the applications of photoelectric effect, let's just learn about the definition of photoelectric effect. Basically, photoelectric effect is the emission of electrons from the metal surface when electromagnetic radiations such as light hit on the material. Then the electrons that are emitted in this manner are known as photoelectrons. Einstein in the year 1905, with the help of Planck's quantum theory, could establish the relationship between the energy of the photons and the kinetic energy of the photoelectrons. He found out that the striking photon had an energy equal to h nu. Here h is the Planck's constant and nu is the frequency of the striking photon. And he also found out that the minimum energy required for the ejection of the electron is W naught, or also known as the work function for that particular metal. With the help of conservation of energy principle, he was able to establish a relationship between the kinetic energy of the ejected photoelectron and the energy of the photons. He found that h nu is equal to W naught plus half mv square. Here h nu is the energy of the striking photon, W naught is the work function for that metal, m is the mass of the photoelectron, and v is the velocity with which the photoelectrons get ejected. So now let's get into the applications of photoelectric effect in electronics. So what is a charge coupled device? Charge coupled device is a kind of sensor that is being used in many of the digital cameras and imaging systems. What happens in charge coupled device is when the photons or the light from the outside environment strikes on the semiconductor surface like silicon, it ejects the free electrons from its surface. Then these photoelectrons are gathered at the same place where they are created. Then the computer counts them to create a digital image. Now let's move on to a different device that is known as light dependent resistor. Which is also known as photoresistor. This is a very small device but has very great applications in day-to-day life. So what is a light dependent resistor? Light dependent resistor is a device which changes its resistance according to the incident light. When the incident light increases sensitive surface, the device decreases its own resistance and hence allows the flow of current through the circuit with which it is connected. So what happens when light falls or the photon falls on the sensitive surface of the device? The electrons in the valence band of the particular semiconductor jump into the conduction band. In order to that happen, the photon should have an energy greater than the band gap of that particular material. Then the current will start flowing through the circuit. So where can LDR be used? Basically, LDR can be used with devices that use light as a triggering mechanism. Like we can make automated street lights with the help of LDR. Basically, the street light would turn off when the light would be incident on the LDR and will turn on when the surrounding areas become dark. Photoresistors can also be used in laser-based security systems. That means when a burglar interferes in the flow of the laser, then the resistance of the LDR will increase, and subsequently it will trigger the mechanism which will result in the buzzing of a buzzer or alarm in the form of light. So with this, I would like to sign out. Thank you.
Thank you, Aravinda. Judges, do we have any questions for him?
Arvind,
yes, sir.
Nice presentation.
Thank you, sir.
Can you tell me what is valence band and conduction band you were telling? Na? What is valence band and what is conduction band?
Sir, every material has a valence band and a conduction band. When the electrons are in the valence band, they are binded to the atom.
How those valence band or conduction bands are produced? What is that exactly? I understood what you told, that when the electrons move from valence band to conduction band, they conduct electricity. But what is that valence band and what is conduction band?
Sir, it is a property of that.
You are from which class? Class 11 or 12?
Sir, 12.
12.
Yes.
So what is the valence band and conduction band?
Sir, sir, that is the property of every metal, non-metal, or semiconductor. When the electron, sir, we assume that there is a valence band and a conduction band. So when the electrons of that metal or the compound are in the valence band, so they are present inside the atom and take part in the bond formation process. But when they are excited into the conduction band, they become free electron and help in the conduction of the electricity through that material.
Okay, thank you.
Thank you, sir.
Okay, nice presentation, Aurobindo. Can we
Thank
move
you.
for the next one?
Thank you, judges. Now I would like to welcome our next participant, Basudev Mahapatra of 11D, to showcase his presentation. Basudev, you can use this platform to present your ideas for the next 5 minutes.
Am I audible?
Yes, yes, you are audible and visible.
Okay. Is my presentation visible now?
Yes, it is. Please go ahead.
Okay. Good morning, everyone. This is Basudev Mahapatra of class 11, here to present on the topic, applications of photoelectric. As you know, the study of photoelectric effect is one of the most remarkable experiments that was conducted in the 20th century. It was discovered by Hertz and rewormed by Sir Albert Einstein. Over the last century, it has a wide number of applications in our day-to-day life. So let's move on to my presentation, where this topic has been discussed in detail. Photoelectric effect. It is the emission of electrons when electromagnetic radiation, such as light, hits a material. The electrons emitted in this manner are called photoelectrons. The classical laws of mechanics stated that both the number of electrons and the kinetic energy were dependent on the brightness of the light, but the results of photoelectric effect showed that kinetic energy of the ejected electrons was independent from the brightness. This is the formula of photoelectric effect. H nu is equal to H nu naught plus half mv square. Nu naught is the threshold frequency below which the photoelectric effect is not observed. And half mv square is the kinetic energy of the ejected photoelectrons. Now let's move on to the applications of photoelectric effect. First one is photoconductive cells. Photoconductive cells are made of semiconductors with band gaps that correspond to photon energies to be sensed. The semiconductors are the material that conduct both heat and electricity at certain conditions, and band gaps are the energy level differences. The most important application is the photographic exposure meters and automatic switches that are used in the visible spectrum and involve a chemical cadmium sulfide. Other examples include the camera light meters, street lights, clock radios, nanophotonic systems, etc. This is the diagram of the photoconductive cell. The image sensors. The image sensor is a device that detects and conveys the information required to make an image. The image sensors are used in electronic camera phones, optical devices. The image sensor shown in this slide is basically used for industrial purposes. This is the third application, photomultiplier tube. The photomultiplier tube is a highly sensitive extension of phototube. The phototube is a vacuum tube that is highly sensitive to the incident light. It contains a series of metal plates called diodes. Light striking the cathode releases electrons. These are attracted to the first diode, where they release additional electrons that strike the second diode, and so on. After 10 diode stages, the photocurrent is so enormously magnified that the photomultiplier can detect a single photon. It has a wide number of applications in the image technology. Here you can see the various applications of the photomultiplier tube: light amplifiers or image intensifiers, television cameras, and the image storage tubes, which use the principle of photoelectric effect. And this is the diagram of the photomultiplier tube. So this was what I had to say on this topic. Thank you.
Thank you, Vasudev, for that amazing presentation. Judges, you can ask your questions now.
Okay, nice presentation.
Thank you, ma'am.
My question is that, do you know what are the types of photoconductivity? You had told one term, photoconductivity. Do you know what are the types of photoconductivity present?
I said about photoconductive cells, so I don't have enough information on the types actually.
You don't have enough information about that. Can you tell me the applications of where the photoconductive cells are used?
Photoconductive cells, as I said, the photographic exposure meters and the automatic switches for street light that use a chemical cadmium sulfide.
Thank you.
Thank you. Next, Vasudev. Thank you.
Thank you, sir.
Thank you, judges. I take this opportunity to invite Master Bharat Tripathi of 11D to exhibit his presentation. Bharat, you have the floor for the next 5 minutes.
Good afternoon, esteemed judges and respected teachers and my dear friends. Today I'm going to present a PPT on photoelectric effect application. Photoelectric effect application, a well-established paradox to the laws of wave theory. Definition. The photoelectric effect is a phenomenon in which electrons are ejected from the surface of a metal when light is incident on it. These ejected electrons are called photoelectrons. The process through which photoelectrons are ejected from the surface of the metal due to the action of light is commonly referred to as photoemission. This is the equipment for studying photoelectric effect. Light of a particular frequency strikes a clean metal surface inside a vacuum chamber. Electrons are ejected from the metal and are counted by a detector which measures their kinetic energy. The paradox. Laws of wave theory suggested that after the light falls on a substance, electrons are emitted after a small gap or instant of time. However, in photoelectric effect, the electron emissions are immediate without a time delay. Now, the laws of wave theory also suggested the number of electrons ejected and kinetic energy associated with them depend upon the brightness of light. However, in photoelectric effect, the number of electrons ejected depend on intensity of light, and the kinetic energy does not depend on the intensity of light. The elucidation. When a photon of sufficient energy strikes an electron of atom of the metal, it transfers its energy instantaneously to the electron during the collision, and the electron is ejected without any delay. If the energy striking the electron is greater than required for ejection, the excess energy is converted to kinetic energy. Now coming to the second most important topic of this presentation, that is applications. With the photoelectric effect set in stone by Einstein, the world soon turned to creating the first photovoltaic cells out of selenium. Although that was replaced by silicon, here's the process at a high level perspective. Photons first penetrate a PV cell which transfers their energy to loose electrons. These electrons get knocked off their orbit in a silicon atom. The loose electrons then seek the path of least resistance towards an empty hole in another atom. But by methods of manipulating electrons, we first make them work by traveling through a circuit. Now, as electrons leave a solar cell as electric current, they pass through a wire conduit and into an inverter. This device transforms what is currently stable direct current into an alternating current that can provide power for homes, businesses, etc. Once our devices and infrastructure are powered, the electric current will then flow back through the circuit of a solar system, finding rest in the solid contact layer at the bottom of a solar panel to create a closed circuit loop. This is a typical solar panel set up in a residential home, and this is how it looks like. Now, some mentions in where photoelectric effect is used. Imaging technology, including older television camera tubes or image intensifiers, and it is also used to study nuclear process and chemically analyzing materials based on their emitted electrons and giving theoretical information about how electrons in atoms transition between different energy states. Thank you. This is all for my presentation.
Thank you, Bharat. Judges, would you like to ask some questions to Bharat?
Yes. You told you showed your. Can you show the slide number 2? I think slide number 2.
Slide number 2. Okay, sir. So the definition.
No, next. चलो आगे चलो.
This one.
आगे.
This one, sir.
Exactly, I cannot catch now.
So this one.
Where I observed, I cannot. आगे चलो. Let us try it. I cannot exactly catch time will be consumed.
Okay.
My question is, you are telling PV cell.
Yes, sir.
And that silicon used, you are telling.
Yes, sir.
In the PV cell, silicon is used, you are telling.
Yes, sir.
So, can light energy eject the electron from silicon?
Yes, sir. The photons knock out the electrons from the silicon
That is a
atom.
pure silicon taken or some impurities you was added?
Sir, pure silicon, sir.
And pure silicon means that is a covalent bond, 4 covalent bonds, and the light energy cannot break the covalent bond.
Sir, actually, in the photoelectric effect, sir, the bottom layer of the silicon is doped with boron, and the top layer is doped with phosphorus, sir.
So that means you are telling that is not a pure silicon.
Yes, sir, that is not a pure silicon, sorry.
That part is not mentioned there, so therefore I asked. Thank you.
Thank you, sir. Thank you, sir.
Thank you, Bharat. Can you go for the next presentation?
Thank you, judges. Now, moving on to the next presentation, I would like to call upon Master Bidhu Bhushan Patra of 11E to showcase his presentation. Bidhu, the forum flow is set for the next 5 minutes.
Sir, am I visible?
Yes, you are visible.
Is my screen visible?
Not yet. Yeah, your screen is visible now.
So, good afternoon, everyone. Esteemed principal ma'am, most honorable judges, respected supervisor ma'ams, and my dear friends. Myself, Bidhu Bhushan Patra from class 11, section E, and from DAV Public School, UNIT-VIII, BHUBANESWAR. And today, in this chemistry seminar, our main topic is about photoelectric effect, and I have chosen this subtopic as photodiode. So, let us begin directly from the topic and its definition. That is, a photodiode is a two-terminal electronic device which, when exposed to light, the current starts flowing in the diode. What does it mean? it means that it is a light sensitive device. Senses light, then current flows through the circuit. And here is the simple diagram representation of the photodiode, and it is operated in reverse biased mode only. Then here comes the Newton. What is reverse biased mode? It is the mode in which the voltage passes across the diode. There are two types, which is across the diode and along the diode. In this reverse biased, the voltage crosses across the diode. And the third point, it converts light energy into electrical energy, as we can directly infer from the definition part. Then comes to construction of photodiode. So this is a physical diagram representation of a photodiode. How is it shown? Now the photodiode is made up of two layers of p-type and n-type semiconductor. In this, the p-type material is formed from the diffusion of the lightly doped p-type substrate. N-type epitaxial layer is grown on n-type substrate. Then the contacts are made up of metals to form two-terminal cathode and anode. The front area of the diode is divided into two parts. Here we can see this is the front part of the diode, and here it is divided into two parts. That is, one is non-active surface and the other is active surface. And non-active surface is made up of silicon dioxide, or that is SiO2, and the active surface is made up of anti-reflection material. It is an anti-reflection material. Now comes to its working and principle of photodiode. So in this first diagram, we can see when the conventional diode is reverse biased, the depletion region starts expanding and the current starts flowing due to minority charge carriers. So when the light rays comes and strike to the junction of P and N type material, then it senses light and the current flows through the diode. Then the same condition can be obtained in photodiode without applying reverse voltage. Now in the second diagram, we can see the junction of photodiode is illuminated by the light source. Here light is coming from a light source to the junction of P and N type. So due to which electrons from valence band get the energy to jump into the conduction band and contribute to the current, for which current flows through this simple circuit as shown in this figure. In this way, the photodiode converts light energy into electrical energy. Let us come to modes of operation of photodiode. Usually there are three modes, that is photoconductive, photovoltaic, and the other one is analvanke. So under photo, but broadly there are two types, that is photoconductive and photovoltaic. So first of all, what is photoconductive? The photodiode operates in reverse biased mode. In this case, the photodiode operates in reverse biased mode. And second point, the current flowing in a diode varies linearly with the intensity of light incident on it. It varies linearly, means uniformly. In order to turn off the diode, it should be provided with forward voltage. The voltage should be forward to turn off the diode. But in case of photovoltaic, the diode is operated without the reverse bias. When the reverse bias is removed, the charge carriers are swept across the junction. The barrier potential is negative on N side and positive on P sides. It is under photovoltaic mode. Now comes to its VI characteristics of photodiode. So here is the graph of the VI characteristics of photodiode, in which we can see lines are drawn. And here in the positive x-axis, that is forward bias in volts, and in the negative x-axis, that is reverse bias in volts. But according to the definition, we know that the photodiode always comes in reverse biased mode. So here we can see that the graph is towards the direction of the opposite x-axis. So the current under large reverse bias is the summation of reverse saturation current and short circuit current. So I naught represents reverse saturation current, and eta represents quantum efficiency, and E represents a charge of electron. And here the equation we got, that is I equal to ISC plus I naught whole into 1 minus e to the power V by eta Vt. So it is the equation from the graph. And here's a note, that is we can see here highlighted, that is dark current. Then what is the dark current? It is a new word coming. The current which flows in photodiode before light rays are incident on it, it is called dark current, or its other name is leakage current. Why leakage? Because According to the definition, we have know that it is a light sensitive device. That is, when light falls on it, then only current flows. But here, direct current, according to this word, current flows in the photodiode before light rays are incident. So it is a special case. In the graph, it is also shown here. Now comes to its advantages of photodiodes. The reverse current is low in the tens of microamperes. This is one point. And second one is the rise and fall times in cases of photodiodes is very small, making it suitable for high-speed counting and switching applications. Its main advantage is accuracy. Because when light falls and current flows, it means a speed work. Na? Then disadvantages of photodiodes. Photodiodes have lower light sensitivity than cadmium sulfide. LDRs, light dependent resistors, those LDRs are considered more suitable for some applications. Means for some applications, LDRs are more beneficial than photodiodes. So this is one type of disadvantages of photodiode. Now comes to applications. Applications are vastly they are present in everyday life, but I will show you some few applications. That is, first one is detection of both visible as well as invisible light rays. That is here in this picture, this is a doorway in which photodetector is there, and from a light source light beam comes. So it is mainly shown in either lifts or some light sensitive doors that are present in showrooms, etc. And second one is communication system for encoding and demodulation purpose. So this is the simple device used in that purpose. Now third point is digital and logic circuits which require fast switching and high speed operation. This is the circuit, simple circuit used in those operations, and here the light rays are coming to the photodiode and current flows after that. Now fourth point is character recognition techniques and IR remote control circuits. It is one of the best discoveries of physical experiment of science, we can say, because in everyday life we are using TV, ACs, and any LED fans. There are many more electronic applications like that. In that case, IR technology, that is remote control, is used. So in automotive use, also we have headlights of vehicles that are automatic dimmers that dim.
Sorry for interrupting, but you have already exhausted your time limit.
This is completing.
Yeah.
Now barcode reader, medical use, X-ray generator, and daily camera use. So these were the applications. So that was all about my topic. Thank you for patiently listening.
Thank you, Vidhu, for the presentation. Judges, do we have any questions for him?
Okay, Vidhu, can you tell me which material is used in photodiode?
Ma'am, which material?
Which material is used in photodiode?
Ma'am, it's silicon.
Silicon, only silicon.
Let me think. Ma'am, it can be all semiconductors, that is silicon, germanium.
Yeah, all semiconductors like silicon, germanium, indium, gallium, arsenide, all these are used as your very good. Nice presentation. Although you have exhausted your limit, but your
remember the time taken.
Yeah, your presentation was very elaborative. Thank you.
Thank you, ma'am.
Nice presentation.
Thank you. Thank you.
Thank you, judges. I take the pleasure of inviting our next participant, Ms. Ekta Dhal, to share her presentation. Ekta, you have the floor for the next 5 minutes.
Is my presentation visible?
Yeah, it is, but your video is not on.
I have switched on my video.
But you are not visible. Yeah, you are visible now. Go ahead.
Science knows no country because knowledge belongs to humanity and is the torch which illuminates the world. A very warm afternoon to respected judges, honorable principal ma'am, teachers, and all my fellow mates. This is Ekta Dhal of class 12 section C. Today in this seminar, I'm going to talk about the various applications of photoelectric effect. What is photoelectric effect? The phenomenon in which electrically charged particles are released from or within a material when it absorbs electromagnetic radiation is called photoelectric effect. The effect is often defined as the ejection of electrons from a metal plate when light falls on it. In a broader definition, the radiant energy may be infrared, visible, or ultraviolet light, and the material may be a solid, liquid, or gas. While the description of the photoelectric effect sounds highly theoretical, there are many practical applications of its work. Photoelectron spectroscopy, photovoltaic cells, imaging technology, television camera tubes, photomultipliers, phototransistors, and scintillators are some of the practical applications of photoelectric effect. Never in the history of science has a subject sprung so suddenly from a state of complete obscurity to a condition of full predictability as has the field of spectroscopy since the year 1931. What is photoelectron spectroscopy? It is also known as photoemission spectroscopy. It refers to the energy measurement of electrons emitted from solids, gases, or liquids by the photoelectric effect in order to determine the binding energies of electrons in the substance. Moving on to the next slide, we have the physical principle of photoelectron spectroscopy. Photoelectron spectroscopy is also an application of the photoelectric effect. The light rays used are ultraviolet light and extreme ultraviolet radiations. For solids, the photoelectrons can escape only from the depth. Photoemission is one of the most accurate techniques for measuring the energies, shapes of electronic states, and molecular and atomic orbitals. Typical photoelectron spectroscopy instruments use helium gas source of ultraviolet light with photon energy up to 52 electron volts. The photoelectrons that actually escaped into the vacuum are collected and counted. This thus forms the spectrum of electron intensity as a function of measured kinetic energy. As the binding energy is more accepted, the kinetic energy is converted into binding energy. This is achieved by applying Einstein's relation, where Ke stands for kinetic energy, which is measured, Hv stands for photon energy from the radiation source, and Eb stands for binding energy, which can be calculated from the other two variables. Types of photoelectron spectroscopy. X-ray photoelectron spectroscopy is a surface-sensitive quantitative spectroscopic technique based on the photoelectric effect that can identify the elements which exist within a material or are covering its surface, as well as their chemical state and the overall electronic structure. Infrared spectroscopy or vibrational spectroscopy is the measurement of the interaction of infrared radiation with matter by absorption, emission, or by reflection. It is used to study and identify chemical substances or functional groups in solid, liquid, or gaseous forms. The technique of infrared spectroscopy is conducted with an instrument called an infrared spectrometer. Nuclear resonance vibrational spectroscopy is a synchrotron-based technique that probes vibrational energy levels. The technique, often called NRVS, is specific for samples that contain nuclei which responds to the Moss-Boyer spectroscopy, most commonly iron. This method exploits the high resolution offered by the synchrotron light sources, which enables the resolution of vibrational fine structures. Because of its versatility, the spectroscopic methods have been widely used for different purposes for the past few decades, from biological applications to the measurement of elemental abundance in astronomical objects. Some of the attributes which makes the spectroscopy methods ideal for use are fast and simple analysis, either qualitative or quantitative is possible, little or no sample presentation is usually required, and they do not use polluting solvents. It is easy to find appropriate calibration standards and methods of analysis that are validated by recognized institutions. Direct and non-invasive analysis are also possible, Normally, non-destructive methods can be employed with a few exceptions, such as the atomic spectrometry methods. With this, I conclude my presentation. Thank you everyone for your patient hearing.
Thank you.
Thank you, Ekta. Judges, you can now ask your questions.
Ekta, can you
Yes,
hear me?
sir.
Okay.
Yes, sir.
You gave one equation that kinetic energy of the photoelectron equal to the energy radiation minus your binding energy. Yes or no?
Yes, sir.
Okay. That means you are assuming the law of conservation of energy is applicable here.
Yes, sir.
But have you seen that photo plates available in the market?
Couldn't hear you. Can you repeat again?
Have you seen the photo cells, photo plates which are available in the market? They are using for the domestic purpose.
No, sir. I haven't seen.
The maximum efficiency is found to be around 12 to 15%. If
Yes,
the
sir.
collision, if the energy of the photons are absorbed, all the energy absorbed by the metals. Means I want to ask that whether the collision between the metals and the photons are elastic in nature. Suppose light energy is W.
Yes, sir.
Are you getting my point?
Yes, sir.
Suppose light energy is suppose 20 joule.
Yes,
that
sir.
20 joule completely absorbed by the metal or some
Sir,
energy.
no, sir. Some of the energy is absorbed.
So if the some energy is absorbed, then we cannot calculate what is the exact kinetic energy. We are
No,
using
sir,
light
we cannot
energy.
calculate exactly, but approximately we can calculate it.
How approximately you can calculate? What amount of energy absorbed, what percentage absorbed, what percentage transferred to the surrounding. If you do not know how exact what is the work function, we know. But what exact kinetic energy, how can you calculate? So what is that exact equation? That Einstein equation. Suppose I'm writing E is the energy of the light radiation, W is the binding energy or work function, and
Sir,
kinetic
but the
energy.
kinetic energy is already measured, sir, of the given substance or metal.
What is that E? You are writing E is equal to W plus kinetic energy, or kinetic energy equal to E minus W, or binding energy, whatever you are telling.
Yes, sir.
But what is that E? Like what the energy of light radiation or energy of the light radiation which is absorbed by the metal?
Sir, I think energy of the light radiation which is absorbed by the metal.
Yes. Thank you.
Thank you, sir.
Nice presentation, Ekta. Can we go for the one?
Thank you, ma'am.
Thank you, judges. Now, I take this opportunity to welcome our next fervent participant, Master Jay Mishra of 11C, to share his presentation. Jay, you have the floor for the next 5 minutes.
Yes, I'm ready to go. Good afternoon, everyone present. I am Jay Mishra and this is my chemistry seminar on Photomultiplier under the topic Application of Photoelectric Effect. Before telling you about Photomultiplier, I would like to have an overview of the photoelectric effect, just a quick one, but this is not our major concern. So photoelectric effect was finalized by Albert Einstein in 1905, which you already know, and it is stated as the phenomena of emission of electron by electromagnetic radiation such as light falling on a material. Here you can see we have taken a same material and electrons are emitted only in 2 cases. This is because of the work potential of different materials and the energy of photon of different light waves. So it was derived with the help of Planck's work and is given by E equals to h mu, where mu is the frequency of the light wave. You can see the violet light has the lowest wavelength, so it has the highest frequency because they are inversely proportional, which means it has a greater energy of photon, and the remaining energy after overcoming the work potential of the metal gets converted into kinetic energy, that is half the mass times the velocity square, which is clearly evident. As you can see, the velocity in the purple scenario is double the velocity in the green scenario. So this pretty much sums up the photoelectric effect. But and now we are moving forward to photomultiplier. It was given by L.A. Kubetsky, a Russian Soviet scientist in the 1930s, and he was the first one to get the idea of a photomultiplying tube using photoelectric effect. His original model looked like this, which was pretty bulky, but with advancement in technology, we have achieved and optimized this to fit to a size that fits right in our palm. So it's a laboratory equipment containing electrodes, diodes, and electrons used to amplify very weak signals of light or a beam of particle. Or simply for a layman, it can be understood as an amplifier. Amplifier to amplify weak beams of light. We'll discuss its use in the next slide. Now, then uses of photomultiplier or the need. Well, there are various needs of photomultiplier, but as the time permits, I'm going to be discussing only two major needs of photomultiplier. The first one is in laboratories, as scientists deal with very small amounts of charge and they need precise and accurate results. So a photomultiplier helps them achieve this with the help of computers too. And the another need of photomultiplier is in space exploration. It helps us view distant planets and stars with a much clearer view, and helps scientists to explore universe to a greater extent. Now let's discuss the how photomultiplier works. A photomultiplier, as you can see, has a structure in which it is sealed with a glass tube and has connections with various voltage dropping resistors, and at the top you can see there is a metal head to cause photoelectric effect. And this structure over here is known as a dynode case, which consists of many dynodes, and this is the vital part of a photomultiplier. In this image, you can see how an incoming photon gets converted into multiple electrons and finally resulting into a beam of electrons, which is further transferred and the output is given to a computer, which then further calculates it and gives the original value to the scientists, helping them achieve their required result. So working principle of a photomultiplying tube can be quite hard for starters, but I will also explain it in the simple manner. A photomultiplier tubes use very faint sources of light. It's a photoemissive device which converts photons, as we have discussed earlier, how a photon gets converted into multiple electrons. And we'll discuss it now too in further scope. This is done with the help of a photon flux generated by a photocathode. So or simply it can be understood like an example of an avalanche. We'll discuss that later. As you can see here, a dynodes are arranged in such a manner to facilitate photocathodes to achieve a factor of 1,000,000 in photon flux, causing secondary emissions of electrons from the circuit. And these voltage dropping resistors are used because there is a greater range of the voltage differences in dynode electrons, that is from 500 volt to 3000 volts. So it can be understood simply like an avalanche, or which you might have seen by throwing a pebble on a mountain, or can be understood by this diagram. You can see a small disturbance of snow over this area caused a greater landslide in this snow. So this pretty much sums up the how working of a photomultiplier is and how it started, how it was discovered. With this, I would like to conclude my presentation. Thank you.
Thank you, Jay, for the wonderful presentation. Judges, we are eagerly waiting for your questions.
Okay, nice presentation, Jay.
Thank
Okay,
you.
my question is, what is the importance of photomultiplier tube in a scintillation detector? Can you tell me that? Can you correlate it?
In what?
Photomultiplier, importance of photomultiplier tube in a scintillation detector. One of your friend gave the presentation on scintillation. Can you correlate that? What is importance? Because this particular part was also presented there. You have taken a section of that. Can you tell me that? What is the importance of photomultiplier tube in scintillation detector?
Well, I don't know much about scintillator, but as I've already discussed, the photomultiplier tube helps in amplifying the results, and I can guess that it amplifies the weak sources of light in the scintillator to a greater amount, resulting in a larger view of the experiment.
Yeah, the output which we are getting, it is in proportion with the amount of scintillation. Okay.
Yes.
So because you had explained what you had explained only, this is the summation of that particular part. Nice presentation. Sir, over to you.
Thank you.
Yes, sir.
Thank you, judges. Now I take this opportunity to invite our next presenter with a great scientific vehemence, Master Jyotiraditya Raut of 12A. Jyotiraditya, you have the floor for the next 5 minutes.
Hello. Hello.
Yes, audible.
Good afternoon, everyone. Present in the virtual meeting, respected judges and all my dear teachers. I'm
Jyoti, your voice is not audible.
Hello. Hello.
His volume is very low, or is it only for me? I am not getting what he's saying.
Jyotiraditya, your voice is quite faint and you are not perfectly audible, and your video is also not on, so please check into that.
Hello.
I think there is some network glitch, so can we just move on to the next performance? Jyotiraditya, we will be taking up your presentation towards the end. Now, I would like to invite Ms. Preeti Parna Rath of 11G to showcase her presentation. Preeti, the forum flow is set for the next 5 minutes. All the very best.
Am I audible?
Yes, you are.
Good morning, everyone. I am Prithipanna Rath of 11G, and today I am going to present about application of photoelectric effect, under which I will be discussing about the photocell. So before we move on to the application of photoelectric effect, we must know what is photoelectric effect. When light shines on a metal, electrons can be ejected from the surface of the metal in a phenomenon known as the photoelectric effect. This process is also often referred to as photoemission, and the electrons that are ejected from the metal are called photoelectrons. In terms of their behavior and their properties, photoelectrons are no different from other electrons. The prefix photo simply tells us that the electrons have been ejected from a metal surface by an incident light. Now moving on to photocell. A photocell usually consists of a vacuum tube with two electrodes. The electrodes are usually two metal plates or wires. One electrode is a photocell in a photocell consists of a metal, the cathode, that will emit electrons when exposed to light. The other electrode, the anode, is given a positive electric charge compared to the cathode. When light shines on the cathode, electrons are emitted and then attracted to the anode. An electric current flows in the tube from cathode to anode. The current can be used to turn to open a door or to ring a bell in an alarm system. The system can be made to respond to light as described above, or it can be sensitive to the removal of light. Now moving on to the application of cells in medicine. Absorption of light by a bacteria cell causes a drop in the number of photons absorbed by a photocell and a drop in the current. Photocells in garage door openers. Light to photocell is interrupted and the corresponding drop in photocurrent signals the motor to reverse. Here is the image of that. There is an infrared emitter and this is a receiver containing a photocell. The infrared emitter emits an infrared light beam which is received by the photocell. If the light beam is interrupted and the photocell does not receive any light, and the corresponding drop in photocurrent signals the motor to reverse and open the door for the upcoming visitor. Do you know this effect is also called the Hertz effect because it was discovered by Henry Hertz, but this name is not used often. Photocells in movie theaters. Optical sound track is like a barcode but much more detailed. The track modulates the intensity of the light at a frequency which is the same as the sound which was used to produce the track. With this, I conclude my presentation. Thank you and have a nice day ahead.
Thank you, Preeti, for that splendid performance. Judges, do we have any questions for Preeti?
Priti, can you tell me
Yes, sir.
that photoelectric effect
Yes, sir.
confirms which character of electron, which nature of electron? You know, electrons have a dual nature.
Yes, sir.
Photoelectric effect confirms which nature of electron.
Which nature of electron?
Yes. Do you know that electrons have dual nature, de Broglie concept?
Sir, I'm not sure about that answer.
Electrons have wave nature as well as particle nature?
Yes, sir. Sir, particle nature of the electron.
Okay. If photons, can you break the photons?
Can the photons be broken down?
Yes.
Broken down?
Possible?
No, sir. I don't think so.
Okay. Thank you.
Okay, thank you, Preeti. Can we move on to the next presentation?
Thank you, judges. The upcoming presentation is going to be presented by Ms. Smruti Pragya, Meher of 11B. Smruti, you have the floor for the next 5 minutes.
Good morning, everyone. I'm Smriti Pragya Mihir of Standard 11B, and I'm going to present the topic Application of Photoelectric Effect. So, photoelectric effect is a phenomenon in which electrically charged particles are released from or within a material that absorb electromagnetic radiation. The effect is often defined as the ejection of electrons from a metal plate when lights fall on it. There are various applications of photoelectric effect, and one of it is photoelectric cell, which is also called as electric eye, photocell, or phototube. An electron tube with photosensitive cathode that emits electron when illuminated and an anode for collecting the emitted electrons. The voltage between the anode and cathode causes no electron in darkness because no electrons are emitted, but illumination excites electrons that are attracted to the anode, producing current proportional to the intensity of the illumination. When the tubes are used in control system where interrupting a beam of light opens a circuit, actuating a relay that, in turn, supplies power to the mechanism that brings about the desired operation, such as opening of a door. The tubes are used in photometry and in spectroscopy. Let's talk about the construction of the photoelectric cell. Photocells consist of an evacuated glass tube containing two electrodes, emitter as C and collector as A, in this given diagram. The emitter is shaped in the form of a semi-hollow cylinder. It is always kept as a negative potential. The collector is in the form of metal rod and fixed at the axis of semi-cylindrical emitter. The collector is always kept at the positive potential. The glass tube is fitted on a non-metallic base and the pins are provided at the base for external connection. Let's talk about the working of the photoelectric cell. Radiation of the frequency more than the threshold frequency of a material of emitter is made the incident on the emitter. Then the photo emission takes place. The photoelectrons are attracted to the collector, which is positive with respect to the emitter. Thus, the current flows in the circuit. If the intensity of the incident radiation is increased, the photoelectric current also increases. There are several applications of photoelectric cell, such as the photoelectric cell is used in the reproduction of sounds, which is recorded on film or a movie. It is also used in exposure meter, and the exposure meter is used along with the camera to know the correct time of the exposure for having a good photograph. It is also used in a lux meter, which determines the intensity of the light, and also used in burglar alarm, which is a device is kept near a safe to be protected from a thief. Thank you for the patient listening, and I wound up my presentation.
Thank you, Smruti. Judges, do we have any questions for her?
Okay, you have once you have heard your friends giving their views, their presentation on the same topic. I just want to know from all this presentation, what are the types of photoelectric cells? In this presentation, all of them have given. You have not given input on that. I just want to know, do you know what are the types of photoelectric cells present?
No, ma'am, I have no idea about it.
Okay. Now, in our daily life, can you tell me where we are using the photoelectric cells?
Ma'am, photoelectric cells are used in burglar alarm and also in lux meter and exposure meters.
Okay. Okay. Thank you. Nice presentation.
Thank you, ma'am.
Thank you.
Thank you, sir.
Thank you.
Okay. Can we go for the next presentation?
Thank you, judges. Moving on to the next presentation, I would like to invite the next presenter, Ms. Sohana Pokhira of 11E, to showcase her presentation. Sohana, you have the floor for the next 5 minutes.
Okay, thank you. I'm starting.
Sir.
Am I visible? Am I visible?
Yes, you are visible.
Is my screen and PPT visible?
Yes, yes.
Okay. Good afternoon, everyone. Principal ma'am, judges, teachers, and my fellow peers. I am Sohana Pakhira of Standard 11E. Today, in my presentation, I'll be speaking about an application
Madam,
of
Mausi madam, mute karantu. Yes.
Shall I continue?
Yes, yes. Continue.
Okay. I'm Sohana Pakhira of Standard 11 Section E. Today in my presentation, I'll be speaking about an application of photoelectric effect in the form of photomultipliers. First, I'd like to speak a little bit about photoelectric effect. The scientific definition would be the phenomena of ejection of electrons from the surface of a metal when a light of suitable frequency strikes on it. In simple words, light with energy above a certain point can be used to knock electrons loose, freeing them from a solid metal surface. Each particle of light, called a photon, collides with an electron and uses some of its energy to dislodge the electron. The rest of the photon's energy transfers to the free negative charge called a photoelectron. The emission of these photoelectrons is called photoemission, which is an instantaneous process. Now, I'd like to say about what is a photomultiplier. It is a device that converts light into an electrical signal, then amplifies that signal to a useful level by emission of secondary electrons. It is essentially a type of vacuum phototube which converts incident photons into electrons. Then the photoelectron flux is amplified by secondary emission process. Photomultipliers are very sensitive light detectors which provide a current output proportional to the light intensity. It was invented by Soviet scientist L.A. Kubetsky in 1930. The basic operating principle of a photomultiplier is photoemission and secondary emission. A photomultiplier is generally seen in form of a tube. We call it a photomultiplier tube. Now we'll see the parts of a photomultiplier tube. It essentially has four parts: the photocathode, the electron optical input system, the electron multiplier, the diodes, and the anode. The photocathode converts photons into electrons. It is a photosensitive cathode which emits photoelectrons when light strikes it. Here is where we observe the photoelectric effect. It is generally made up of photoemissive semiconducting materials like silver, oxygen, cesium, or antimony cesium. Now we have the electron optical input system. It focuses and accelerates the photoelectrons towards the useful part of the first dynode. Now we have the electron multipliers, the diodes, which are a series of secondary emission diodes of secondary emission electrodes, which are placed successively in the order of a higher positive potential, which leads to the multiplication or the amplification of the photoelectron flux. Now we have the anode, the collecting anode, which collects the electron flux from the multiplier or the diodes and supplies the output signal. Now we see the diagram of a photomultiplier tube here. It is a vacuum phototube in which we see an incoming photon ray which strikes on the window, the input window, which is usually made up of quartz or glasses like borosilicate glass or lime glasses, which can control the spectral sensitivity, and then it strikes on the photocathode where photoemission takes place. These photoelectrons emitted are focused by the focusing electrode, then it strikes on the strategically placed diodes. Then we see that as it strikes each successive diodes, the electron flux multiplies, and at the end, we see that the anode has a very highly amplified electron flux. It is important to remember that successively as we see the diodes towards the anode, the voltage, there is a higher potential, and it increases as we go towards the anode. Now we'll see the operation of a photomultiplier. The light is absorbed on a photocathode and then it generates photoelectrons by the external photoelectric effect. The electrons are accelerated with a high voltage, which can be hundreds of volts, to the first dynode, where they generate several secondary electrons. Those are accelerated further towards the other diodes, where the number of electrons gets several times larger each time. Finally, a very strongly amplified photocurrent is collected with an anode near the last dynode. Here in the GIF, we can see what happens inside a photomultiplier tube. We see that the number of rays or the flux is getting larger as it reaches the anode. Now we'll see the advantages of other photodetectors. It has a large light sensing area, the ability to detect low electromagnetic radiation due to amplification. This is possible due to an avalanche amplification process, which takes place in the photomultiplier tube, giving it very high sensitivity. An ultra-fast response and excellent timing resolution can be achieved. It has a high gain and low noise device, a lower dark current, which is actually a property of the photocathode. The disadvantage is that any spurious signal like a stray radiation is also amplified in the process due to high sensitivity of PMTs. Now we'll see the uses of a photomultiplier, which is used to detect low energy photons in the ultra visible to visible range. And it can also detect some of the infrared lights too. It depends on the input window, which actually controls the spectral sensitivity of the photomultiplier tube. And high energy photons like X-rays and gamma rays and ionizing particles. It is used in medical diagnostics and imaging, like flow cytometry, blood inspection, hygiene monitors, etc. In night division devices, spectrophotometers, and high-end image scanners. It is also used in portable radiation and other pollutant measurement devices. In astronomy, it is used to measure the intensity of faint star. A solid-state photomultiplier, like a silicon photomultiplier, is more compact and versatile and are used for distance measurement in LiDAR, light detection and ranging, in medical equipments and high-energy physics features. With all this, I conclude my presentation. Thank you for patiently paying attention to my presentation.
Thank you, Sohana, for that wonderful presentation. Judges, do we have any questions for her?
Yes, I have one question. Sohana, thank you. Very nice presentation.
Thank you, sir.
First question, you have already told that in electron optical inputs, photons are accelerated. How the photons can be accelerated? My first question. Electrons can be accelerated because you applied electric field,
yes,
and electrons being charged, that is no problem.
So the diodes.
But
so the diodes have a higher potential, positive potential. It attracts the photoelectrons. Can we say that?
Now, you told that electron optical inputs, you told that photons are accelerated, not electrons. Photons are accelerated.
Oh, okay. Sorry, sir. I must have misprinted it.
Photons have no charge,
no, sir, it is wrong. The photoelectrons actually.
The second question, my second question to you, is there any spin of photon? Is there any spin of photon? You know, electrons have spin, where
yes,
quantized by plus half and minus half.
Mm-hmm.
Is there any spin of photons?
No, sir.
Do not know or no spin?
No, sir, it does not have a spin.
No spin? No photons have spin.
Okay. Sorry, sir.
And what is the difference between electron spin and photon spin?
Sir, I have no idea about the photon spin. I cannot explain it. Sorry, sir.
Okay. Photon exists in discrete form in single form, but electron cannot exist in single form. You are paired electron.
Yeah.
Electron always exists in paired form. So therefore, we are giving plus half. So one electron spin is half. It is either plus half or minus, that is different issue on the basis of the direction. So what is half? But photon exists as independent, one photon. So it is spin is one.
Okay, sir.
Okay, thank you. Nice.
Thank you, sir.
Yes, Sohana, nice presentation.
Thank you.
Okay, so we have Adya, I think. We have two left, Adya and Jyoti.
Now I would like to invite Adya Archita Patnaik of 11B to please present her presentation.
Good afternoon, teachers and my fellow friends. Today, I'm going to speak on the topic, the applications of photoelectric effect, photoelectric cell. Photoelectric effect is the phenomenon of ejection of electrons from the metal plate when exposed to lighter frequency more than the threshold frequency of the metal. The characteristics are pressure frequency is different for different materials. Photoelectric current is directly proportional to light intensity. K of photons is directly proportional to light frequency. It is an instantaneous process. Stopping potential is directly proportional to frequency. The photoelectric effect is best seen in the photocell or photodiode, which is an electronic device that converts light energy into electric energy. They can operate in remote locations, produce direct current DC, have power or current that depends on surface area exposed to sunlight. There are three types of photocells, namely photoemissive cell, which is of two types, vacuum type or gas type. It consists of two electrodes with photosensitive material like sodium, potassium, or cesium. Anodes, which is a straight wire made of nickel or platinum, and it also consists of an evacuated glass or quartz bulb. It is used in television, photometry, file alarm. The next is the photovoltaic cell, which is based on inner photoelectric effect, which generates EMF without applying any external potential difference. It consists of a film of semi-transparent metal coated over semiconductor layer formed on a metal plate, either by heat treatment or cathode sputtering. It is used in photometers, illumination meters, photographic exposure meters. The third type is the photoconductive cell, which is also based on the inner photoelectric effect. It consists of a thin film of semiconductor like selenium or transparent metal film. Iron-based and transparent metal film is connected to battery and resistance. It is used in alarm systems, security devices like motion sensing lights and cameras, light meters, and making street lights turn on and off automatically according to the level of daylight. The photocell is used also in many appliances like for sound reproduction from motion picture. In a movie, film sound is recorded on a thin transparent soundtrack. Using photocell, sound is reproduced from the soundtrack. When the film is run, light is passed to the soundtrack onto a photocell connected to an amplifier to a loudspeaker. Solar cell, it is used to convert the sunlight or solar energy into electrical energy. Next is the burglar alarm, which is a device kept near the safe to protect valuables from thieves or intruders. It consists of a photocell and an infrared light source. Light is made continuously incident on the photocell, thus photoelectric current in the cell flows continuously. When the path of light is obstructed by the thief, light falling on the photocell is cut off and the current in the cell stops. Relay circuit is activated and the siren starts shooting. The next is the garage door system and the fire alarm system. And the last is the exposure meter, which is attached to a camera to know the correct time of exposure of film for a good photograph. And the last is the lux meter, which is used to determine the intensity of light. Thank you.
Thank you, Adya. Do we have any questions for her?
Okay. Now, Adya, tell me, yes, in photoelectric effect, we are using semiconductors. So semiconductor is of which type of device? Semiconductor is of which type of device?
Ma'am, semiconductors are some materials which provide conductivity between conductors or non-conductors or insulators, which are better known as insulators.
Okay. So we are using in photoelectric effect, we are using semiconductors to convert which energy to which energy?
Ma'am, the light energy into electrical energy.
Light energy to electrical energy. Okay, now tell me, let's say if we are using photodiode sensor, do you have any idea about that photodiode sensor? You have told now? You have used the word photodiode sensor in presentation.
Yes, ma'am. Ma'am, it is kind of a light sensor which converts the light energy into electrical energy to use it as electric.
Okay. Now, can you tell me if we are using, as you know, your photodiodes are made of photoconductive materials. Okay.
Yes, ma'am.
So if the photoconductive materials are used, will the conductivity change or will there be, will it change or will it not change?
Ma'am, can you please repeat the question?
Let's say photodiodes are made of photoconductive materials. Yes or no?
Yes, ma'am.
Now, if we are using photoconductive materials, will the conductivity change or it will not change?
Ma'am, it will change.
It will change. Okay. Thank you. Nice presentation.
Thank you, ma'am.
Over to you. Over to you, sir.
Thank you. Next.
Thank you, judges. Now I would like to invite Master Jyotiraditya of 11A for his presentation.
Is my screen visible? Hello.
Yeah, your screen is visible.
Good afternoon, everyone. Present over here. I'm Jyotiraditya Raut of class 11A. I want to throw some light on photoelectric cell, which is a part of an application of photoelectric effect. Let's start our presentation. Then what is photoelectric cell? Or what is photoelectric effect? Photoelectric effect is a phenomenon in which electrically charged particles are released from or within a material when it absorbs electromagnetic radiation. The effect is often defined as the ejection of electrons from a metal plate when light falls on it. It was discovered in 1887 by German physicist Rudolf First, as this relation was between light and electricity, hence it was called as photoelectric. Then what are the laws of photoelectric effect? Photoelectrons are ejected by a metal surface when the frequency of incident radiation becomes equal or greater than the work function of the metal. The number of photoelectrons emitted per second is directly proportional to the intensity of incident radiation. The maximum energy of the photoelectrons do not depend on the intensity of incident light, but relies on the frequency of the light. Then what are the applications of photoelectric effect? First, automatic burglar alarm, then photometry, then photoelectric cell, and photomultiplier tube. Then what is an photoelectric cell? What is photoelectric cell? A device that used to convert light energy into electrical energy is called photoelectric cell. Based on the phenomenon photoelectric effect, it is based on the phenomenon on photoelectric effect. It was proposed by Albert Einstein in 1905. There are three types of photoelectric cell, such as photoemissive cell, photovoltaic cell, and photoconductive cell. Then what is photoemissive cell? There are two types of photoemissive cell. One is vacuum type or gas filled. It consists of two electrodes. One is cathode and anode. Cathode is coated with photosensitive material like sodium, potassium, or cesium oxide. Anode is made up of straight wire made up of nickel or platinum. Then it evaporates. The vacuum is made up of evaporated glass or quartz ball. Then photoelectrons flow from cathode to anode. Then the gas ionize the gas field and hence current gets modified. Then photovoltaic cell. Photovoltaic cell based on the principle of inner photoelectric cell. It is called as true cell because it generates electromagnetic radiation without any application of any external potential difference. It consists of semiconductor layer formed on the metal surface spread by heating or treatment or cathode splittering. A film of semi-transparent metal is coated over the semiconductor. And photoconductive cell. It is also based on the inner photoelectric effect. It consists of thin film of semiconductor like selenium placed below a semi-transparent metal. The iron base and the transparent metal film is connected through a battery and resistance. When the light falls on the cell, its resistance decreases and the current starts flowing in the external circuit. Then application of photoelectric cell. Then reproduction of sound in cinematography. Then control the temperature of furnace. Then automatic switch on and off street lights. Then automatic opening and closing of the door. Then electrical energy from sunlight during the space travel. Then burglar alarm used to detect theft and fire. By this, I'm ending my presentation. Thank you.
Thank you, Jyotiraditya, for that presentation. Judges, do we have any questions for him?
Okay, tell me, what is stopping potential?
Sir, can you tell the question again?
Your friends just discussed different things about the stopping voltage. What is that exactly?
Sir, I could not get you, sir.
You can hear me?
Sir, no, sir, clearly not audible. Sir, can you tell again?
You are using cesium oxides are used. Sodium, potassium, cesium oxides are used.
Yes, sir.
In cathode. Why we cannot use cesium metal? Why oxides are we are using? I could not get that one. Can you explain what are the benefits when you are using cesium, sodium, potassium oxides instead of those metals?
Hello.
Okay. Thank you.
Hello.
Very nice presentation.
Sir, am I audible, sir?
Yes, audible.
Sir, cesium, sir, it is used, sir, cesium oxides are used for, sir, it converts sunlight energy into electricity, sir.
That I already, many friends who discussed that when light falls from the metal, electrons are ejected, but you are using cesium, sodium, potassium oxides.
Sir, the electrons in cesium atoms are stimulated by direct sunlight. And in photoelectric cell, these electrons flow to create an electric current. So, sir, cesium is an ideal catalyst, sir, for this photoelectric process.
Okay. Thank you.
Thank you, sir.
Thank you, Jyoti. Nice presentation.
Thank you.
Thank you, judges. The chemistry seminar themed on applications of the photoelectric effect has successfully reached its end, and the results will be declared later on. Truly, it was a great learning experience for each one of us. I take immense pleasure to extend my heartfelt thanks to our principal ma'am, Mrs. Ipshita Das, for giving us this very platform and opportunity to exchange scientific thoughts and ideas. This event has reached its pinnacle of glory due to the colossal contribution and guidance of our chemistry teachers who helped us in every possible way. I extend my hearty thanks to the revered judges who graced this event and encouraged our fellow participants to excel in their presentations. I would like to express my gratitude to the technical staff of DAV Unit-VIII who have made this event possible on the virtual platform. I feel pride to acknowledge and thank the contribution of all the participants who have given the best of presentations to make this seminar one of its kind. Finally, thank you everyone for joining this event and making it a grand success. On that note, I would like to sign out. Keep learning, keep exploring. Thank you everyone.